Jaca number 4 coming up. 3 dots, and I've reorganized this a little bit so we have a sort of folder structure here and we can go and get these here. Number 4 is this one and we are downloading it. Let's have a quick look. We have data and it looks good, and our int also looks excellent. Got a formula, so we're expecting a metal complex here. To solve it, just type the word solve or work your way around the GUI, and shellXT returns a more or less finished structure. So let's just carry on with that and refine this a few times. Now I don't want that many lines. I'm just going to type line 6, so we have a few lines in the background here. Now that looks pretty good. This is a bit suspicious. It could be an ammonium ion, but most likely it's a water molecule, but Control M might help us. Well, first of all, there's quite a bit of green around that, so that probably makes that an oxygen. So we can pick up the O here and then click on it. It's another way of doing that. And then hit escape to get out of this mode. The other thing that's noticeable, this nitrogen here is probably not a nitrogen, but an oxygen. Now, a little pitfall here, you can't click on this when it's got a map on top, but we can use Shift and the left mouse and select them and then make it an oxygen. The problem is we also selected some Q peaks, so it pays to be a bit cautious here, and now we can just delete those peaks. So sometimes you make a change in atom type of a Q peak when you don't want to, and that can make a bit of a mess. So just be careful about this. Control R to refine that. And that now looks okay-ish. So let's make it anisotropic, all of it. So this oxygen is quite a bit bigger than the other atoms here, but it's in the solvent sphere, so it's rattling about a little more. So it's not really surprising that that's the case. Right, so let's do HAdd. So I'm just typing this, or I could have clicked on this. It comes to the same thing. And refine this again. Control R. That looks pretty good, 3.38%, and we have a couple of other things to briefly talk about. Well, firstly, Control M as always. So around the metal, that's to be expected, but this doesn't look too good. So that hydrogen placement again. Now, if you look at this, clearly it's not over here, so this is red. There shouldn't be a hydrogen here. I'm using Alt and the mouse and can zoom in a bit. And it's here, but that looks sort of, it's a head-on water molecule and not an angled one. So the default is this angled one. So what we're going to do, I'm selecting all of this and then kill $H and press this button. It doesn't delete all hydrogens, only the hydrogen atoms of the selection. So if I refine this now again, just to get the Q peaks back to have a little look at this, Control Q. So they're really sort of head-on hydrogen. So the best way to get them is HAdd -R. So it places them the same way it did before, but now it's free to move any which way it likes, but it's restrained. So the hydrogen atoms do not run away, and they're restrained. So they're sensible with respect to the metal, but they're not, they're not constrained. They're now restrained. Okay, so this looks pretty good. Control M now, so we've got something around that cobalt. It depends a little bit on how big the crystal was. It's whether the absorption correction was done properly, but this looks all pretty good. Now, this also looks quite good. It's a bit dodgy, so let's see that also. If you look at this, it does look, it's like bent. So first of all, let's switch on the weighting scheme like we did before. If you do that, the R factor has gone down a little bit, but this curve, the oval curve, is still here. So this is 100 and this is nowhere near 100. So when that happens, that's extinction. So you tick that box and refine this. And yes, the R factor goes down significantly, and this is now a straight line. So extinction has been dealt with. Control R, and I think by the time we refined a few more cycles, let's refine 12 cycles. OLX2 refine will stop when it's done, so you can't really have too many. That looks pretty good. Control M, just the last check. That looks sensible to me. Is this a hydrogen atom? No, look, it's 0.4. It's very, very little here. I can't see anything else. Let's click on info. refinement indicators, nothing red here. So everything looks good. Bad reflections, no bad reflections reported. So I think the structure is pretty much done. Control M. And we can do a final cycle, switch the actor on. So we actually have a zip file that we can report somewhere. There's a little orange symbol here. That means the formula here does not agree with what's on the screen. It's a bit of a strange one. It actually does agree the atom count is correct, but the official convention in crystallography is CH and then everything else alphabetically. So here the cobalt is at the end. So this is maybe by choice and by design, because if you have a series, maybe you want the metals last. The official rule would be the formula should be like this. So when this doesn't conform to the rule, or when what's on the screen does not agree with that, then there is this little orange thing. So it means you can press on this and now it's gone, and the formula will now in the zip file be in the correct order, if that's accepted. But I guess it is really up to you how you want that, but it's important to be clear about that. There's something else about the structure. If you look at this, there's a cobalt that doesn't really have anything going away. And that's because Control G actually will make this grow. So this one is actually an extended solid that keeps going out. So you can keep growing this. Yeah, so this is not just a molecular thing. This is a continuous solid that we've got. We can also grow things. So this is now it's got a complete and coordination environment. So does this, but this one doesn't. You can also select this, and in toolbox work at the bottom there is this growing. Yeah, that's the one growing, and you can go shell. So this will now grow it only once. If you click on that, you get that atom. So you now have a coordination sphere of the metal. You can right click on this and show the polyeder as well. So you go, oh, auto doesn't do the job here. Interesting. So polyeder and go regular, and then you get the regular polyeder that you can display. One of the things, of course, is this water molecule. We're only seeing one at the moment because we only grew the metal. So what you really need to do here is grow -W. So this will also then complete the coordination sphere with all the water molecules. It actually made another one of those because it needed that to make that water molecule. So we're in the situation again of needing to grow the shells. So you don't need to select something first. You can actually click on that, and that now completes the shell. And then you should see a picture that might be sensible for you. We've got 1, 2, 3, 4, 5 water molecules and 5 metals. So that's what it was. Those bonds in the middle are a little bit strong. If you do have the Draw Plus plugin, and you've got this Control J key, and that makes the sort of dotted bonds in there. More about plugins later, but this is just showing that there are ways of showing doing the display slightly differently. Of course, you can type the word cell, and then you see the cell, how it lies in there. Type the word cell again to get rid of it. I think that's enough for this structure. Thanks for using OLX2.